Every physics textbook for the last 30 years says the universe expands forever, drifting apart into a cold, dark emptiness with nothing left. New data says that might be completely wrong. Dark energy, the mysterious force discovered in 1998 that pushes every galaxy away from every other galaxy, was always assumed to be constant, a fixed and unchanging property of empty space itself. Under that assumption, the ending was inevitable. Stars burn out one by one, distances between galaxies grow beyond anything imaginable, and everything fades into permanent silence, an ending physicists call the Big Freeze. For nearly 3 decades, that was the ending scientists were confident in. New data arriving between 2024 and 2026 has put that ending in serious doubt. The first crack appeared in 2024 when the Dark Energy Spectroscopic Instrument, a project using one of the most advanced sky mapping telescopes ever built, released its first full year of results. Against nearly every expectation in the field, the data suggested dark energy might not be constant after all. Its strength appeared to be changing over cosmic time, weakening rather than holding steady, a possibility so unexpected that physicists spent the following year testing it from every angle before taking it seriously. Then, in November 2025, a separate and completely independent line of evidence arrived. Researchers found that the standard method for measuring cosmic expansion using the brightness of a specific type of exploding star had been subtly miscalibrated. Those stars appear to dim slightly differently depending on the age of the stellar population that produced them. When that correction was applied, the data stopped supporting the idea of an eternally accelerating universe and instead matched a model where dark energy changes over time, exactly the pattern the DSI results had already hinted at. If dark energy is genuinely weakening, the implications are enormous, because the ending we have been told to expect for 30 years may not be the ending at all. In February 2026, a physicist at Cornell University ran the numbers all the way to their conclusion. According to the calculation, if dark energy continues weakening the way current data suggests, the universe will keep expanding for roughly another 11 billion years, reach its largest possible size, and then begin to reverse, not drift apart forever, but collapse. Galaxies that spent billions of years growing farther apart would begin moving back toward each other, faster and faster, the entire universe contracting toward a single point in an event physicists call the Big Crunch, calculated to occur roughly 33 billion years after the universe began. That is a genuinely different ending than the one built into nearly every cosmology textbook of the last 3 decades. But before treating this as settled, it is worth being honest about where the science currently stands, because not everyone agrees. In June 2026, a team at the University of Southampton re-examined the same supernova data using a more careful calibration method and reached the opposite conclusion. Once host galaxy environments were properly accounted for, they found the evidence for an accelerating universe remained just as strong as it has for 30 years. One of the original scientists, who discovered dark energy back in 1998, responded directly to the weakening dark energy claims, saying that extraordinary claims require especially careful testing, and that his team's own reanalysis found the evidence for acceleration remarkably consistent with the original result. This is what a real, unresolved scientific question looks like in real time. 2 highly capable teams using the same fundamental data, reaching different conclusions because the effect being searched for is subtle enough that tiny differences in method can shift the outcome. Nobody is being careless here. The universe is simply not making this easy to measure. What is clear is that dark energy, whatever it ultimately turns out to be, is far less settled than the phrase cosmological constant ever suggested. Whether it holds steady forever, slowly weakens toward a big crunch, or behaves in some way nobody has proposed yet, the honest answer today is that the ending of the universe is genuinely back up for debate, decided not by assumption but by data still being gathered, refined, and argued over. A new generation of surveys, including one project expected to map 50 million galaxies by the end of this year, is being built specifically to settle this question. Until then, the fate of everything remains open. What do you think? Is dark energy quietly running out of strength, or is the acceleration exactly as steady as it has always been? Let me know in the comments. Subscribe, because next time we are covering the Big Crunch itself in detail, what the final moments of a collapsing universe would actually look like, and how far off that ending might really be.